Hi, this is I think it's approximately a 2002 model small John Deere light tractor. This particular one, LT150, whatever your model is, I'm pretty sure they're all about the exact same thing. Was having a charging system problem, and like all good 21st century mechanics, I got on YouTube to see if I could figure out what the problem was, although I already had a pretty good idea. And there were some videos out there. I noticed, though, they're very lengthy. They don't really get to the point, so this one's going to be short, right to the point. The symptoms were, well, the battery's about a year old, replaced last season, and worked okay. Over the winter, I top charged it about once a month. So when I started mowing this spring, everything was good for a while, but then I was getting slow cranking, and top charged the battery. Worked good for a while, but once again, pretty soon back to the slow cranking, and checked the battery charging voltage, and I found that it was in the range of about 12.7, 12.8, which is about a volt too low for summertime conditions. Should be seeing something in the range of 13. On an 85 to 90 degree day like today is, I would expect to see a top charging voltage of about 13.7, 13.8 for a fully charged battery. Anything more than that and you're going to be overcharging the battery. A lot of folks will tell you you need to be up over 14 volts. Not true. Not in the hot weather. In the winter time, when most people do mess with charging systems, yes, that is applicable. A lot of people don't realize that your charging voltage will vary with the battery's temperature. Anyway, here's what we'll find. If you're having a problem, you might take it to your local mechanic, John Deere dealer. Prior to spending any money, there's a dirt simple fix that you need to look for. Check your charging voltage across the batteries terminals. See what it is. If it's running below 13 volts, you've probably got an issue. A little background on how these systems work. Underneath this fan housing, there is a flywheel. The top of it, all these little engines are pretty standard. The top of it is has fan blade fins on it to move air across the cylinder heads. And underneath, there is usually a machined out compartment or whatever with magnets mounted in it. And the flywheel fits over a stator, which is nothing more than a little frame with coils of copper wire wrapped around it. And that would be, yeah, here's the, this runs up to the stator, which is mounted up underneath there. Two wires come out of that, runs to the voltage regulator here. There's two wires that parallel, those two wires take the alternating current down to the ignition module, which pops the voltage up and feeds it to the spark plug. If you've got a spark and this engine runs, there's nothing the matter with the stator. If your mechanic wants to change that stator, it will fix the problem, but it's not the problem. Then they may also tell you you need a new voltage regulator. And if he changes that voltage regulator, it will fix the problem, but it's still not the problem. The problem is a basic design flaw, and that's why I wanted to make this video, is because I got a feeling it's applicable to a lot of these same tractors. So if you're experiencing this, try this first. Went to check the voltage regulator. The first thing I noticed, this ground strap was loose. It's tight now, and I'm not going to untighten it for reasons I'll explain later. Here's the design flaw. Whoever designed this voltage regulator intended that the housing be mounted on a ground. Whether it's Kohler's fault, John Deere's, I don't know, but it's mounted on the plastic shroud, so that's no ground. How they got around that was to put this grounding strap here and take it down and ground it to looks like a throttle cable mount so it can find ground. Works. That's great. This is a self-tapping screw, and it just simply, that's why I'm not going to take it loose. It's a self-tapping screw that goes into this plastic shroud. Well, over time it gets loose. That develops a little bit of resistance here, At first it's not going to be bad, but then you get corrosion, a little arcing, pitting. Pretty soon the resistance increases. What I was probably seeing was you probably had about a 1 volt voltage drop across this. So the voltage regulator says, okay, I'm putting out the right amount of voltage, 13.7 or so. But because of that voltage drop, the battery is only seeing about 12.5 volts. Not enough to keep it fully charged. Just simply take the screw out, clean up, polish both the housing on the voltage regulator and the terminals. If they are pitted, corroded, then you might want to consider replacing the entire terminal. In my case, I was able to get away with just polishing it up and reinstalling it and torquing it down. You can't torque it too much because, once again, it's a self-tapping screw and you're just going into plastic. So to me, that's the design flaw. If I was to start it up and crank it over now, I'm getting about 13.7 volts across my terminals. That's enough to keep my battery charged. It's the appropriate amount for this ambient temperature of about 85 degrees, I'm guessing, out here. So it's all fixed. And didn't cost me any money. Like I say, replacing the stator, you obviously would remove this, etc., reinstall it. It's going to work. You think you fixed it. Replacing the voltage regulator, obviously, you fixed it. But it's money wasted. All it was just a little looseness on that connection right there. Hope you find this helpful. You know, you may still have a bad stator. There isn't a whole lot that can go wrong with that, though. It's just unless maybe something physically goes through there and chops a wire. That's pretty unlikely, I think. And of course the regulator could go bad. But before you spend any money on those expensive parts and a mechanic's time, just check that connection for looseness there. And well, down here too, for that matter. But here you're going screwed into and torqued into the metal of the engine, so I don't think you're going to lose torque on that one quite so much. But do make sure it's tight, since you're here anyway. And like I say, since I'm just screwed into plastic there, maybe someday I'll come up with a more permanent fix. But for right now, that's fixed it. And hope you found the video helpful. And like I say, we'll keep it short. Bye-bye.